Okay, we have here something called an Atwood machine. It's basically just when you have two weights of unequal mass hanging over a pulley or something, and one's going to pull the other around the pulley. So in this situation, there's a few things to do. The first thing it asks us to do is find the rate of acceleration. And the big thing to understand is whatever rate the large block accelerates at, it's going to be equal to the acceleration of the small block, because this is a rigid rope. If this big block moves a meter, then the small block is going to move a meter. So their accelerations are connected, they're all the same, which gives us the power to analyze this entire thing as a system. So in this case, we can say, all right, what is the driving force of this system? So we have a 7-kilogram mass that's going to be pulling this down with a force of 70 newtons. Once again, I'm assuming G is 10 meters per second squared for simplicity. So it's being accelerated at 70 newtons from this block. That's sort of the driving force behind it. Now, if it weren't attached, that would be the force pulling it down. But it's also being pulled by 30 newtons on this side. So it's feeling 70 newtons in the accelerating direction here, but it's also being held back by 30 newtons. Now, what can be confusing for some people is that both of these forces are down, but the pulley up here is essentially changing the direction of this 30 newton force. The 30 newton force is effectively pulling the entire system up at 30 newtons. It's holding it back. So don't be fooled by the fact that it's in the downward direction. Bottom line, the net force on the entire system is the difference between these, or 40 newtons. So this entire system is being accelerated by a force of 40 newtons. And one way you can think of this is if these masses were the same, their difference would be 0, there would be no net force. It would just hang there forever. So anyway, the net force is 40 newtons. So Newton's law, right, the net force equals the mass times acceleration. We know the net force is 40 newtons. We know the total mass is 10 kilograms. So we can solve for A. A is going to be 4 meters per second squared. And this is reasonable. We know it must be less than 10, because this block on its own would accelerate at 10 if it weren't connected to this other block. So it must be less than 10. If we got over 10, something is wrong because somehow it's accelerating faster than it normally would. So here's the trickier part. Calculate the tension on the rope. So we have a choice here. We can analyze either block, the big one or the small one. Let's just pick the big one because I already have it circled. So if I draw a force diagram on the big block, I know there's 70 newtons pulling it down. And I know there's some tension force, T, pulling it back. I don't know the tension force yet. But I do know how much this block is accelerating. So I know this is a 7-kilogram block, and I know it's accelerating at 4 meters per second squared, which means the net force on this block, F net, is 7 kilograms times 4 meters per second squared, or 28 newtons. So this block, pretending that all this, the rest of the system did not exist, it's just somehow feeling some force, we don't know where it comes from, on this rope, but this thing has a net force of 28 newtons. And so if this thing has a net force of 28 newtons, we know the 70 newtons from the weight, what is the tension going to have to be to give me a net force of 28? So I take the difference between 70 and 28, and I get 42 newtons holding it back. So that is the tension on the rope, 42 newtons. Now, I can double check this with the small block. Here's the small block. It's being pulled down at 30. If it's the same rope, it should feel the same tension of 42 newtons. So the net force on the small block is 12 newtons. And let's calculate the acceleration of the small block. So 12 newtons equals the mass of the small block, 3, times acceleration. A, once again, equals 4 meters per second squared. It checks out. It's the same. So there's a lot of ways for you to check your answers on these. There are 3 basically systems we can look at in that machine. You can look at the large mass by itself, the small mass by itself, or the entire system. But in all 3 cases, the acceleration is the same, and the tension on the rope is going to be the same for both blocks, because if one's pulling it up, well, this actually comes to a third law. If the large block pulls on the small block with a force of 28 newtons, the small block pulls on the large block with a force of 28 newtons. So that also kind of works out there. Anyway, till next time, I am Derek Genova. Have a delightful day.